Hi, welcome back. Today is the day where we break the 1 day or the 24-hour breaks, comparing what we get in the TruMatch box, which is our curing box that has water bath in it, and it is curing the cylinders 12 miles away, mind you, at the exact same temperatures that is in the wall for the top of the wall. As you can see here, we have 3 cylinders, 3 sensors in 3 different locations. We got the bottom of the wall, we got the middle of the wall, and we have the top of the wall. Now, we selected the top of the wall, as I said, to be conservative. There's 2 reasons that we picked that. Number one is that the concrete at the top of the wall is anywhere from 2 to 2.5 hours younger than the concrete at the bottom of the wall. So we know that the younger concrete is going to be the weakest. The other part is that we believed that we would have the most heat loss out the top of the wall. Okay, so if you have more heat loss, you're going to have lower strengths as well. And that kind of is indicative if you look right here in the middle of the wall. You see our cylinders green, which means we've already reached our design strength, and it's predicted to be by the maturity curve. The maturity curve estimates that part of the wall is going to be 38-33 or 38-38. The reason for that is because currently this section of the wall is curing at 128 degrees. So kind of interesting stuff. But if you go up here to the top, this curve shows the history of the pour in a way. The temperature inside that form, because the probes were already set there, was 37 degrees prior to the concrete coming in. When the concrete hit the probe, it hit it at 56.5 degrees. That was our mixed temperature when it arrived on the site. Throughout the course of the day, that temperature continued to increase all the way to the point to where right now we're at 110.1 degrees. So that's your thermal curve. But what we're going to do now is, if we look here, you got 3 different temperatures. What the maturity system is doing now is it's estimating the strengths of those 3 levels. And the bottom level is now at 3269. The middle level is already above our design strength of 3500. That's why this cylinder reflects as green in color. Green, you're good to go. Yellow means that you're within about 10% of your desired strength. And then if these cylinders were red, you got a little while to go before you even need to watch them more closely. So we're going to check and see how close this 3172 is to what the actual tests are. So Chris is going to break the cylinder now, and we'll compare it. Go ahead, Chris. In the interest of time, after he's done breaking this, we're also going to break the plywood box, curing box cylinders, and we're going to break the one in the temperature control box. And we'll compare them to what the actual concrete is. And part of the experiment for that is to show that most cylinders cured in the field, despite what kind of cure box you use, are not accurate. They don't reflect the true strength of what the wall is or what the structure that you're using is. So the question becomes is, why are we still using it? At this point in time, shouldn't we be looking at advancing ourselves? Because technology is advanced, why can't we turn around and change some of the rules? A lot of ready-mix producers out there, they pay a large price sometimes for what appears to be low-strength cylinders that come out of these type of boxes, especially in the wintertime. And there's no reason for these ready-mix producers to be paying a price for that anymore when you have the ability to see what the exact in-place strength is. And that's one of the things that's really important, something I want everybody to consider, because there's unnecessary claims sometimes that occur because we're using equipment that's not efficient enough to do the job in giving us the answers that we're really looking for. $32.40. So we projected that the brake was going to be at 3172, and it came up at 30 what?
3240.
3240. So the actual strength of the cylinder is higher than what we predicted, which is what we're trying to do. Whether you're setting up the maturity curve or whether you're monitoring the weakest point in the wall, those things are important because you want to be predicting a little less than what the strength is. Belt and suspenders type application. But we're going to break the other two cylinders. Don't need you to watch that all over again. We'll report the results and we'll talk to you in a little bit. Have a good day.